Okay guys, so today we'll be doing this past year question paper from 2016 paper 1 core. uh, yeah uh, let's begin with question number 9. The diagram shows a ball hanging on a string. The ball swings from point W to point Z and back to point W. Which statement about the ball is correct? A. The kinetic energy of the ball is greatest at point W. The kinetic energy of the ball is greatest at point X. The kinetic energy of the ball is greatest at point Y. The kinetic energy of the ball is the same at all points of the swing. Now, this is a very important question and an easy one as well. At this point W, the kinetic energy is not the greatest, of course, because at this point the bob is going to come back to its mean position, and momentarily the bob will be at rest and it will be having its highest potential energy at this point. Okay, the kinetic energy of the ball is greatest at point X. Now at point X, it says the kinetic energy is max, which is again not the case. Fine. The kinetic energy of the ball is greatest at point 1. This is your correct answer. Fine, because at point Y it would be having maximum kinetic energy, because once it shoots from point Y it will again keep on increasing the height, so its potential energy is going to increase while as its kinetic energy is going to decrease. So it's at this point Y its kinetic energy would be the greatest. Okay, part D says kinetic energy of the ball is the same at all the points of the swing, which is definitely wrong. Okay. Question number 10. No, it's a very important question. Again, a person in a factory has to lift a box onto a shelf. You can see there is this high shelf and there is this low shelf. And the person, she has to lift this box. Which action involves the person doing the least amount of work? Fine. Now you know that work, it's a conservative force. It only depends on the initial and final position. It doesn't depend on the path taken. Fine. Now, point number A says lifting the box quickly to the high shelf. Now, the quickness of the work, I have already explained it in the class. The quickness of the work is not has nothing to do with the actual work. It's basically your power. Fine. How quickly you can do a particular task represents your power. It has nothing to do with the work. So lifting the box quickly won't do anything. Lifting the box slowly, same. Lifting the box to the low shelf first, then lifting it to the high shelf. Like I said that it only depends on the initial and final point. So in case of part C, if she lifted the box to the low shelf first and then lifted it to the high shelf, she's technically traveling or lifting the box through the same height. Fine. So it doesn't matter whether she puts it in low shelf first and then to high shelf. Fine. Okay, part D says lifting the box to the low shelf instead of to the high shelf. Okay, so this one is your correct answer. Lifting the box to the low shelf instead of to the high shelf, because in this case only the distance is, let's say, h1. In the second case the distance was h2, and clearly h2 is greater than h1. Fine. So here it would be having more gravitational potential energy. Fine. And therefore work required would be more. Okay. Question number 11. Which is a non-renewable energy source? Coal, solar, tides, wind. Now, a non-renewable energy source, coal is a non-renewable energy source. Question number 12 we haven't done yet. Okay, I hope you can answer this question. Which is a unit of wavelength? In chapter light, we have discussed this. Hertz is not the unit of wavelength; it's the unit of frequency. Meter per second is again not the unit of wavelength; it's the unit of speed. Second is the unit of time. We are left with just one option, which is meter. And since wavelength is simply the length, it makes sense. Question number 23. Which diagram correctly shows a ray of light reflected by a plane mirror? Now this is a plane mirror and there's a ray of light. Now the incident ray and the normal, this is your normal and this is your incident ray. Alright. Now the angle made is 40 degree, while as the angle between the reflected ray and the normal is 50 degree. Fine. While as the law of reflection states that angle of incidence is equivalent to angle of reflection, which means that part A is incorrect. Part B, you can see this angle between the mirror and the incident ray is 50 degree, angle between the normal and the reflected ray is 50 degree. Fine, which is again wrong because this is defined as the angle of incidence, not this. Fine, so it means angle of incidence is only 40 degree because this is a right angle here. Fine, if this is 50 degree, 90 minus 50 would be 40 degree, and angle of incidence is 40, angle of reflection is 50. Again, this is wrong. Part C, it says it's roughly the same as part B. The incident angle is 40 degree, while as the angle between reflected ray and this mirror is only 40 degree, which means angle of reflection is 50 degree. Fine. So again, this question is wrong. This part is wrong. Now I'll look at this one. The angle between the mirror and the incident ray is 50 degree, which means 90 minus 50 is 40 degree, which means the angle between the normal ray and the incident ray is 40 degree. And here again, the angle between reflected ray and normal is 40 degree. So here angle of incidence is equivalent to angle of reflection. So part D is your correct answer. Okay, a ray of light is incident on a glass prism. Question number 24. So there's a ray of light passing through a prism and now it will be refracted. Which ray diagram shows the ray as it passes through the prism and emerges from the opposite side? Now I very well explained this question in the class. In fact, I gave 2 full lectures on this alone. You know that when a ray of light passes through the prism, it instantly is refracted. Fine. Number one. Number two, violet is least refracted, violet is most refracted, red is least refracted. So in this case, violet is definitely most refracted and red is least refracted. But refraction takes place here. So not the right answer. At this point also, it says red is most refracted while as violet is least refracted. Wrong. What about this one? Obviously wrong, because it's the violet which is most refracted and red which is least refracted, and that happens as soon as this ray of light enters the prism. So part C is your correct answer. Okay, we have not taken magnetism yet, but I think you should be able to do question number 28 because magnetic field lines are very similar to electric field lines. So can you guys tell me what does this represent? The diagram shows the magnetic field around 2 bar magnets. Fine. Which diagram shows the poles of the magnets? Now here I should tell you, magnetic field lines, they originate from the North Pole and enters the South Pole. Fine, so this is definitely the North Pole, and since there is lateral repulsion, there's a lateral pressure, and yeah, this is also North Pole. So I think part C is your correct answer. Both are north poles, but I'll be explaining that in magnetics. Which produces an electromotive force? A battery, a filament lamp, a resistor, a spring balance. I've told you about this in detail. And a battery produces electromotive force. It makes the electrons in the circuit flow. And definitely, you know, electromotive force is not a force. They just named it so. Okay. The table describes four different resistance wires. They're all made from the same metal. Which wire has the smallest resistance? Now I told you that if they are made from the same material, then resistance only depends on the length and the area of cross section. I've told you that resistance is equivalent to rho L upon A. Fine. Rho is material dependent, so if they are all made from the same metal, it means the rho is same. So all we got is length and area of cross section. Length of the wire is 2 meter. Diameter of the wire is 1 meter. Length of the wire is 2 meter. Diameter is 1.5 meter. Length of the wire is 3 meter. Diameter is 1 meter. Length of the wire is 3 meter. Diameter is 1.5 meter. Now we can modify this equation. Let's assume that this is a circular wire. All wires are circular, and area would then be equivalent to pi r square. It will be equivalent to pi r square, and let's say r is d by 2, which it is. Radius is half of the diameter, so we'd got pi d square by 4. 4 will be reciprocated, will go up. So your resistance will depend on your length and the square of the diameter. Fine. Now we'll take case 1, RA, let's say. For RA, resistance would be equivalent to L. L is 2. Fine. And then 1 square. So that would be 2. RB would be 2 divided by 1.5 whole square. So that would be 2 divided by 2.25. So that is 0.89. Let's calculate RC. RC would be equivalent to 3 divided by 1 square. That's simply 3. And RD would be equivalent to 3 divided by 1.5 square. Fine. That's again 3 divided by 2.25. So 3 divided by 2.25, 1.33. So you can very well see that RB has the least resistance, has the smallest resistance. Fine. Because its length is small, but its diameter is 1.5. Okay. I think I'll be stopping here because of the time limit. Thank you very much.